Look at it. Saturn, the jewel of the solar system. For centuries, it's been the icon of cosmic beauty. Those rings, impossibly thin, impossibly vast. Like a cosmic vinyl record spinning in the void. But here's the thing. Saturn isn't just a passive ornament. Beneath that serene gold and ochre exterior, a world of extremes, supersonic winds, storms older than nations, a churning interior where helium falls like rain and carbon crystallizes into diamonds. Today on Ever Curious, we're going beyond the postcard view into the real Saturn, a planet of rings and storms and staggering mind-bending physics.
Ever Curious, learn what you love.
First, let's correct the myth. Saturn's rings aren't solid. They're not even mostly ice in the way we imagine. They're a dynamic swarm trillions of particles, from dust-sized specks to boulders as big as houses, all orbiting Saturn independently, like a billion tiny moons. The rings span over 280,000 kilometers, wide enough to fit 6 Earths side by side, yet at their thinnest. They're only as thick as a football field is long. That's a ratio like a sheet of paper stretched across a football stadium. And here's the kicker. They're young. Data from NASA's Cassini mission revealed the rings likely formed just 100 to 200 million years ago around the time T-Rex first walked Earth. How? Probably from a shattered moon or a comet torn apart by Saturn's gravity. Think of it, the most iconic feature in the solar system? A recent addition. Now, let's talk storms. Saturn's atmosphere is a tempest factory. Winds hit 1,800 kilometers per hour near the equator, over twice the speed of sound on Earth. But the crown jewel? A giant persistent hexagon at the North Pole, each side longer than Earth's diameter. This isn't CGI, it's real. Observed since Voyager, confirmed by Cassini, and it rotates with eerie precision, completing one turn every 10 hours, 39 minutes matching Saturn's true rotation period. How does a hexagon form in a gas giant? Fluid dynamics. In a fast-spinning fluid, jet streams can stabilize into polygonal shapes, something we've replicated in lab experiments with spinning tanks of water. And then every 20 to 30 years, a great white spot erupts, a planet-encircling storm larger than Earth, visible from our backyard telescopes. The 2010 storm lasted 200 days. Its lightning was 10,000 times more powerful than Earth's. Why? Seasonal heating Saturn's year is 29 Earth years, so seasons last 7 years. When northern spring hits, sunlight triggers massive convection. Beneath the clouds, things get weird. As you descend, pressure builds millions of times Earth's sea level. First, hydrogen stays gaseous, then becomes a liquid. Deeper still, it turns metallic, a bizarre state where hydrogen conducts electricity like copper. This layer rotating rapidly generates Saturn's immense magnetic field. But here's my favorite part, helium rain. Near 10,000 kilometers down, helium droplets condense out of the liquid hydrogen and fall like rain. As they sink, they release gravitational energy, helping explain why Saturn radiates more heat than it receives from the sun. And deeper, carbon atoms, squeezed and heated, form soot. Then graphite. Then diamonds. Yes, diamonds. Models suggest tons of diamond hailstones sink toward the core each year, only to vaporize in the heat before reaching the center. Saturn doesn't work alone. It's 146 confirmed moons. Yes, 146. Sculpt and sustain the rings. Take Pan and Daphne's tiny shepherd moons that orbit inside the rings, their gravity clearing gaps like cosmic snowplows. Then there's Enceladus, a frozen world with a subsurface ocean and geysers shooting water 500 kilometers into space. Cassini flew through them and found salt organic molecules and hydrogen, hinting at hydrothermal vents on the seafloor. And Titan, bigger than Mercury, with rivers, lakes, and rain, but of liquid methane. Its thick nitrogen atmosphere, complex chemistry, and subsurface water ocean make it one of the top candidates for extraterrestrial life in our solar system. So why study Saturn? It's not just about one planet. Saturn is a laboratory for physics testing how matter behaves under extremes we can't replicate on Earth. It's a window into planet formation, how gas giants shape solar systems. And it reminds us, beauty and violence aren't opposites in the cosmos. They're partners. Those rings, born from destruction. Those storms, powered by sunlight and spin. That diamond rain, a byproduct of pressure and chemistry. Saturn doesn't have rings and storms. It is rings and storms forever in motion, forever evolving. A world where science and poetry orbit the same truth. If you're ever curious about what lies beneath the surface, subscribe, hit the bell, and let me know in the comments. What should we explore next? Jupiter's Great Red Spot? The ice volcanoes of Triton? Thanks for watching. Stay curious.